Okay then, question 21. So, the sum of angles in a triangle is 180. Prove that the sum of angles in a quadrilateral is 360. Well, we know this is true, but we've got to show it, we've got to prove it. So, it tells us the angles in a triangle is 180. It gives us this picture of quadrilateral. So, the way you do this is any quadrilateral, any four-sided shape, that's what a quadrilateral is. Any four-sided shape, you can cut it into triangles. So if we cut this in half, like this, I've just made it into two triangles. So we know all the angles in each of these triangles are 180. So that one, and that one, and that one is 180, all added up together. 180 degrees. And then we know this one, and this one, and this one, they're all 180 as well. So if that one and that one and that one, so imagine like we had like 60 and 60 there. Just imagine 60, 60, 60. I know it doesn't look like it, but just imagine 60, 60, 60. And here we could have 60, 60, 60 as well. Now if you added all of these up, 60, 60, 60 plus this 60, because that's a big angle now, that's actually 120 now. That one, those two, they'd be both 120 together. That's a 60 and that's a 60. All together, you'd get 360 all added up. So that's why, and that's how you'd prove it. So you'd have to explain this. You'd have to explain you've got 180 degrees there in that triangle, 180 in that triangle. All together, that makes the 360 degrees. So that's that one done. Okay, now this one down here in the diagram, ABC, that's a straight line, and BD is the same as CD. So that's to put these lines here. That makes this into an isosceles triangle. Two sides are the same. So let's just work out the size of angle X. Okay, this means this is an isosceles triangle. Because those are both the same, that means this angle and this angle, they're exactly the same because it's an isosceles angle. So this triangle, because it's a triangle, the angles add up to 180. So if this is 120, we can do 180 degrees, take away the 120, and that gives us 60 degrees. So these two added up have got to be 60. Because it's like these lines are the same, it makes it isosceles, so both of these angles are the same. So we can just halve the 60, so 60 divided by 2 is 30 degrees. So both these angles here, this is 30 degrees, and this is 30 degrees. We've got 30, 30, 120, all together 180, so 30 degrees. Work out the size of angle Y now. So we've got to work out this angle here. Now we know from up here, this shape here, that's a quadrilateral, and it sits up here, that's 360 degrees. We should know 360 degrees for the angles in a quadrilateral. We know this angle here, we know this angle here, we're working out this one. If we could find this angle here, we could work out this one from the 360 degrees. Let's work out this angle here. Let's call this Z. Let's work out Z first. So Z, this is a straight line. Angles on a straight line always add up to 180. Think of like a protractor. It's 180 degrees, like half a circle, a semicircle. So these two angles are 180. If this is 30, this angle here, to 180 minus 30, which is 150. So this angle here is 150 degrees. So now, using our 360 for a full four-sided shape, we can work out this angle. So let's do that. So let's add up these. So we've got 150, 54, 108. Add them up. 4 and 8 is 12. 5 and a 5 is a 10, and a 1 is an 11. 2 and a 2 is a 2, and a 1 is a 3. That's 312. So whatever's here adds up to 360. So if we do 360 minus the 312, that'll tell us how big this angle here is. So 0 take 2, we can't do that. Borrow from the 6. 5, 1. 10 take 2 is 8. 5 take 1 is 4. 3 take 3 is nothing. So this angle here is 48 degrees. 48 degrees.